In this question, a spacecraft travels between Earth and the planet. The speed of the spacecraft is v, and the distance between Earth and the planet is d, as measured by an observer on Earth. We are asked to identify the Earth clock's reading and the spacecraft clock's reading when the spacecraft arrives at the planet. To find the answer, we'll use the time dilation formula from the data booklet. Here, gamma is the Lorentz factor, and delta t0 is the proper time interval between two events. So the key thing we need to figure out in our question is whether the Earth clocks or the spacecraft clocks measure the proper time interval. So let's recall that the proper time interval is the time measured between two events that take place at the same position in space. Now the two events in our question are the spacecraft passing Earth and the spacecraft arriving at the planet. The key here is to realize that it is according to an observer on the spacecraft that these two events take place at the same position. Put differently, according to an observer on the spacecraft, both of these events take place at the position of the spacecraft, so at the same position in space. Therefore, in our situation here, the proper time interval is a time measured by the spacecraft clocks. So in our formula on the right-hand side, delta t is the reading on the Earth clocks, and delta t0 is the reading on the spacecraft clocks. Let's first calculate delta t. Doing this is straightforward, because we simply need to divide the distance measured by an Earth observer by the speed of the spacecraft. Hence our answer will be A or B. Let's now substitute in the time dilation formula, also using the Lorentz vector formula. Doing so, we get that delta t, so d over v, is equal to the Lorentz vector, so 1 over 1 minus v squared over c squared under the square root, multiplied by the time measured on the spacecraft clocks, so by delta t0. Rearranging from here, we get that delta t0 is equal to d over v times the square root of 1 minus v squared over c squared, which is answer option A.